Hi, welcome to my session. This is second session. First session, I have gone through the AI basics fundamentals. So you are you have got an overview of AI by my first session. Today we are going to learn about its branch, which I mentioned yesterday, that is machine learning, the first branch. As I said yesterday, AI has different subset. First subset is your machine learning. Uh, Here, yesterday, you remember I have given the first branch is AI, the first subset is ML, that is your machine learning. It is nothing but like some algorithms will be there in the machine learning. So, how the machine learning works by algorithms only, some set of algorithms. As we know, for last 2 decades, we have much data captured by many applications like your e-commerce applications, healthcare applications, and many more. As part of AI, it is majorly data. As I mentioned yesterday, like when people are using internet, so they are using different applications, the healthcare applications, e-commerce applications, finance applications, and many more. So the applications capture the data which is provided as an input by the user in the machine. So machine learning, what it does, it learns those particular input data by the system. See, as machine learning is the sub domain of AI, it is not always that all machine learning, uh, like the all machine learning are AI, but all AI are not mandatorily machine learning. There are some rule based implementations which are labeled as AI, but it is not part of your machine learning. We need to program for those rather than studying of the data. As I mentioned in my last session, applications like your Amazon, Uber, Blinkit, or Google Map, they use AI. Those applications use machine learning majorly, as these are data driven applications, because we used to get some data output from those by implementing those machine learning, like fuzzy logic system. Nowadays some refrigerators are using those fuzzy logic systems that cannot be implemented by machine learning, but yes, that is part of AI, but it is not machine learning because it is not data driven. Now, to understand machine learning in a deep way, let's go by some scenarios. If you are going to a bank and apply for a loan, there are some criteria based on which bank may approve or reject your loan. So those criteria might be your salary or your education or your credit score. So those, there are different like criterias on which bank detects, okay, the past data it will analyze, and they will be either approving or you're rejecting your defect. So bank will be having many past data, right? So as for all those data, different criteria would be present in the bank database. So it is the first step to study and analyze those data, which is nothing but machine learning used to do that. And that step, we call it as training. The studying or analyzing of those past data is called training by machine learning. So it is nothing but learning of the past data. So now when a new loan application or a new customer comes to bank, which machine learning, what they will be doing by analyzing the data which they have done as per the past data from the bank, now it will predict as per the parameters of new customer loan applications whether the loan should be approved or rejected. As per that, it will give an output. So the logic which it has implemented, like logic is nothing but the the analysis of the by analyzing the past data from the bank, it will come to a conclusion. How it will come to a conclusion? By some logic. That is nothing but we call it as a model in your machine learning. So that coming to a prediction, we call it as prediction or inference. You remember these two things: one is your training, one is your prediction or inference. Training is nothing but analyzing the past data, and prediction is nothing but analyzing those data by getting some logic from those previous parameters from the data and coming to an output giving some prediction is called prediction or inference. So there is some logic is found by training, that is analyzing your past data, which is called model. So as per that machine learning predicts it. So these two steps, training and predictions, are majorly the two steps which machine learning does in AI. This is one example I have just given, the bank one for the loan, but we can detect in many domains like your healthcare domains. You can get spam or not spam of emails, delivery time by your Instamart or Swiggy or Zomato. We are getting some delivery time, na? Expected time it will take for the rider to come to your home, the destinations which you have provided. So machine learning helps in predicting those information and gives some output. So, in a nutshell, if we say what is machine learning, it is nothing but it helps the systems or computers to understand different data patterns and make predictions as per the logic it is determined by analyzing the past data. Now, you might be thinking how it is different from the like the normal system algorithms, because I said like it is a set of algorithms, nothing else. Machine learning does. See, in the normal program algorithm which the traditional system does, we have some input. You remember, like we have some input, then there is some logic, then there is an output. But here in machine learning, what it exactly does is, you know, like in the bank loan applications, it will first analyze the inputs and the outputs, like the customers who has applied for loan that might be approved or rejected. So it will analyze everything. So here we will be giving the input as input plus output. Then by that it will analyze and derive a logic or a model. So mention it here, input in machine learning is input plus output. So once that input and output is given, the output here will be the logic, or we call it as model. So machine learning works in that way. But before, how it happens, it was an input and some logic works on that, and we used to get some output. But here input output we will be giving as an input to for machine learning, and by analyzing that it will come to a logic or model. As per the logic or model, it will we will be implementing in different features. But it is not like that all the machine learning take input and output both as input parameters, which you'll see in the later sessions in the Python programs and all. But here you can sense like how machine learning exactly the algorithms work. Like in overall machine learning works in this way. Now coming to the machine learning, what are the types, major types of machine learning? Now there are as I mentioned here, I have mentioned you have training and interface or prediction. They are the two steps which machine learning learns does. That is retaining the analysis of the past data, and it will predict as per that. Okay. Now the three types of your machine learning. That is, one is supervised learning, one is unsupervised learning, and one is reinforcement learning. So now let's understand what is supervised learning. Okay. Supervised learning, it is when the logic is implemented or the model is derived. You know, like the logic and the model, like so machine learning used to analyze the past data. By that data it comes to one logic or model. It is when it is derived from a labeled data. What is the labeled data? Labeled data is nothing like, if you need to detect a spam email or it is not a spam email, you want to make learn Gmail or Hotmail or Reddit mail or Yahoo mail. We need some training data, right, to analyze that. So like the emails where the spam emails, you know, the past spam emails, if you see, the text will be something different. The sender, the name of the sender will be different. There will be links, there should be exclamations and all. So as per that, we'll put it as an inputs where those are spams or not. As per this training data, we will mark or label the email as spam or not spam. So now email service will get the training by label data and predict when a new mail comes as per the past data inputs, like the, as I mentioned, like the sender name or links or like the the exclamation marks and the body of their particular email, it will be quite different, as you know, like we know in the spam emails. As for that, it will study, and when a new mail comes, it will mark it as spam or not spam. Now, the supervised learning has two categories. One is your classification category, one is your regression category. So, what is this classification category and what is this regression category? Classification category is nothing but we should have two categories in result output. Like if you have appeared for an example, sorry, if you are you have appeared for an exam, you will be either passed or it will be failed. There is no other things will come out as a output. It will be either pass or fail, positive or negative, right? Some so this classification has two types, that is one binary and one multi-class. Binary is nothing but when the result will be having your loan, whether it will be approved or rejected, no other things will be coming as an output. So that is your binary. Multi-class, you can see like the sentiments, the how the sentiments, like if I say an example, weather is not good, or like it might be, some people say yes, some people might say no. For them it might be no because it is as for them, right? And some people might be neutral. It is not like that mandatory that with yes or it might be no. So as per the sentiments, so it has the classification is of two types. One is your binary and one is your multi-class. Now there is another problems we they used to handle, that is your regression problems. It has regression problems is nothing but it will have the output as numericals outputs only. Like an example like Zomato, Swiggy or Blinkit, like it will the time taking for arrival. Now when you get the output in the applications, it will show like some numeric values of the time for the rider to take to reach your destination. That will never be an yes or no or something like that. It will be like some 2 minutes or 5 minutes or 10 minutes or 10 15 minutes, whatever data. As per the past data analysis, the system will provide you the exact numeric value as an output. So that is your regression ones. Now the examples of your supervised learning, the classification one and the regression one, we talked. For the classification ones, the algorithms, there are some algorithms which is used in the market, that is your linear classifiers, your k-nearest neighbor, knn, your support vector machine, SVM, or logistic regression. So these are the algorithms which machine learning uses as part of your classification category. Now we understood about the classification supervised learning. Now we'll go to unsupervised learning. So what exactly is unsupervised learning? Like I said, in supervised learning, it will train from the labeled data, but here it learns from the unlabeled data. Unlabeled data means what? Like as for example, we have different news. Like there is somewhere some applications which will be having news, but that news might be of tech news, some politics news, or some sports news, some finance news. So how exactly it will work? Like it will classify, it will have some make it as some classes or categories, or we call it as clusters. It helps in like detecting those classes, and as for that it will give some output. But it in unsupervised learning, it helps in you're detecting the anomalies sometimes, like the cyber security threats. Like if an application is there, like when thousands of people are logging into the application, one person is logging in 2 minutes, you can see he is logging, or he or she is logging in seven different areas. So that is some kind of anomaly, we can say, which will not come under any clusters or any class. We cannot mention it in the machine learning, and that we can detect it by using that your uh, unsupervised learning technique. Under unsupervised learning, we have also two categories. One is clustering, one is your association. So clustering is nothing but we create some classes or clusters or groups, as I mentioned. It has two. It has also two groups, like one partitional and one is your hierarchical. Partitional is an example. We have some as I mentioned, like some news is there, but you can partition it as whether it's finance news or politics news or sports news. So we can partition it as differently. In hierarchical, there may be one data point which relates to different attributes. Like for an example, there is some conflict in a sports. There is a news, but you cannot put it in sports only category. You can put in sports news. You can put in politics news. So in different news categories you can put. So by that hierarchical category, we can have that unsupervised learning output being published. So for the clustering, we have these two categories, and for association, there is another one category of unsupervised learning, that is your association problems. That is in you know, like in e-commerce site, if you go uh, sorry, in e-commerce site na, sometimes you will go to the site and it will show you items bought together. If you are buying some item na, with that particular item, it will show you to get another item, like bundle kind of things. So the items, but together it will show in the screen. You might be interested on buying that. Maybe an example I'm giving, if you are buying some fruit juice, along with that it will show to buy some fruits. So those combinations, as per buying history, e-commerce sites, so you, that is your nothing but association. Now the last part of machine learning your is your reinforcement learning. So reinforcement learning is nothing but like what to say, it is like the logic learned by interacting with the environment to get the positive or negative result. You like an example I'm giving, in snake and ladder game, you know, if you get ladder you will go up, and if you cut by snake then you will go down. But in one shot you are not reaching to the end. There are multiple runs which you have to move to, and um, go to the last step to win the game. So by this learning technology, reinforcement learning technology or technique, we will feed positive value on for correct prediction and negative value for incorrect prediction to the system. But there will be multiple moves. It's not like that one time it will give some output. The main motto of that is by multiple moves, or it is mostly implemented in game applications and all. The logic is to maximize the positive value to sum up with at the end to win, or the less value will be losing that game. Now, so this is all about your reinforcement learning. Now, the I have mentioned here, you can see the for classification for the supervised learning, these are the algorithms which machine learning uses. And for unsupervised learnings, this k-means clustering, hierarchical clustering, PCA, principal component analysis, these algorithms which machine learning uses. And for reinforcement learning, your Q learning, deep Q networks, DQ, and policy guided methods. These are some of the examples which we use as algorithms in machine learning. But like now we learn the concepts of machine learning. We understood the concepts of machine learning and AI. In the next session I will go for the deep learning. But yes, like we understood the concepts of machine learning, but practically to implement those, we have like we should know like how we will be implementing those practically. By hearing by this, you will be getting to know the basic, the fundamental concepts of machine learning and your AI. Now, there are different tools available in the market to implement it. But the major thing which we should be knowing a programming language for the machine learning. The most used programming language is Python, which is very popular to write your algorithms, the different algorithms which I mentioned in machine learning. So R is there, but like many people nowadays, for technical perspective and for the academic one also, Python is being used mostly. I will be sharing one Python session too after the end of AI sessions. The next session I will be posting for deep learning. Then the next session I will be posting about Gen AI. Then we'll go for Python training. So this is all about your machine learning, which we have covered today. Please go through this session and the first session also. Then we'll go for the neural network, sorry, the deep learning session in the next class. Thank you. Thank you so much.